So by the way, I'm doing problems that are already worked in the packet so you can look them over again. So we're going to do example 4.4. S of 0 equals 2, S of 1 equals 9, S of n equals 6, S of n minus 1 minus 9, S of n minus 2. And you can skip over the ax to the n stuff, because if I have two terms, I know that S of n is going to be x squared. S of n minus 1 is going to be x, and S of n minus 2 is going to be 1. So I showed you the derivation, which means that actually, if you have a whole bunch more terms, you'll have a polynomial that's the characteristic equation that would have higher powers. I set it equal to 0 by moving everything to one side. And then I can probably factor this with 3's. Now the trouble with this is my formula that I memorize, which is once I have two roots, I multiply the first one by a constant and I multiply the second one by a constant. However, any constants that these are, they could be added and this would just be 1 constant times 3 to the n. So I need to separate them. So I wouldn't get a double root unless there was something weird going on, and what that is that this is multiplied by n. So if you have a double root, you multiply the second term by n. It's exactly like partial fractions and derivatives. Yes? You have heard it before. Yes?
When you say a double root, you mean that it's a function squared?
Well, it's a double root because it's repeated. So 3 is a root of x minus 3, and it's a root of x minus 3. So I have two roots for this equation. So the roots are where the equation equals 0. So if the equation equals 0 twice at that place, it's a double root. So if I had x minus 3 times x minus 3 times x minus 3, that'd be a triple root. So this is a double root. So however many terms, if there was a third term, I'd have to multiply and it was a 3, I'd have to multiply the third one by n squared.
So if you always, whenever you have two of the same root, you just pick one of them and throw it out. If you have 3 of the same root, would you pick 2?
If you have 3 of the same root, so if my characteristic equation was like this, and this totally can happen, I just won't give you a problem like this, you would get c1 3 to the n plus c2 n 3 to the n plus c2 n squared 3 to the n. That's what you would do. Well, I'm not going to give you any problems like that. So if that didn't make any sense to you, you can delete that from your brain. Yes? This is exactly like differential equations. Yes? Yes? Yes, it should. So this is an aside. So if that didn't make sense, just don't write it down. Okay, now we have to figure out what C1 and C2 are. We use our basis for that. So we have S of 0 equals 2, S of 1 equals 9. And then I write down my formula, C1, but I plug in a 0 for n. Notice that I'm not skipping any step. I'm not skipping anything. I'm writing down everything. I totally recommend that you do that. Because a lot of the times if you're like, oh, that's a 0, so I don't have to write anything down, you're going to mess it up. So just write it down. And then multiply it out and say, oh, that whole term is 0. And this is actually just a 1. So we have C1 equals 2. And then I can plug it in. So we get 9 equals 2 times 3 plus C2 times 3. Okay, so 9 equals 6 plus 3C2. 3 equals 3C2, so C2 equals 1. So now I plug that back into my formula. And that's my final closed form. I only need a basis when I have a recurrence. When I have a closed form, I don't need a basis. So I have, I'm going to spend the rest of the time working some problems from your